Alright, we'll try it this time with sound. So, let's see. Main thing is you have 600 feet of fence. That means width, if you're going to use, let's start with this guy. If you're going to use width of 100, you got to use 100 on both sides. So you have used a total of 100 plus 100 equals 200. So that's your first move. First move is to add or times by 2 whatever you use for width. And then move number 2 is going to be, since you have 600 total, you're going to subtract what you have used, and that will give you what you have left over. Step number 3, if there's 400 feet of fence left to use, you must do 400 divided by 2, and that leaves you with 200. So your length is going to be 200 if your width is 100. It's got to add up to 600. 2, 4, 5, 6. Okay, same thing if it's 150. If you're going to use 150 on each side, move number 1, you do 150 times 2, you've used 300. You're going to take 300 from the total of 600, gives you 300 left, divide that by 2. That means 150 on top, 150 on bottom. So you can go ahead and fill out the table, but this guy right here, B, wants you to write a function that represents the length as a function of the width. So what if your width is x? Just follow these 3 steps right here. Step number 1, let's do x times 2, or x plus x, and we're going to total 2x. Step number 2, just like we did with the numbers, let's do 600 minus 2x, and that's as far as you can go. But step number 3, let's cut that in half, and you can actually cut each of those terms in half. 600 divided by 2 is going to be 300, and then negative 2x divided by 2 is going to be negative 1x. So right there is my formula. My formula is going to be, to calculate the length, I'm going to take 300 minus, and x in this case is our width. So I'm going to take 300 minus whatever the width was, and let's test it out. So to find the length right here, the width was 100, so I'm going to take 300 minus 100, and it should give me a length of 200. Length, take the width is 150, 300 minus 150 is 150. There you go. So right here is your function. Okay, C wants you to find area. Area is just length times width. So I'm going to take my width, which was just x, and I'm going to multiply it by my length, which was 300 minus x, and there you go. If you want to distribute and simplify, you're going to have 300x minus x squared. D, determine the maximum of all those combinations. Which width and length will give you the greatest area? And if I go back to my table and I calculate all these rectangles, the rectangle that is closest to the square will give you the greatest area. So if you're building a pen for animals and you're concerned with area, build it as close to a square as you can. So if I multiply all those, 150 by 150, your area should be quite a bit larger than the others. Okay, let's talk about gravity. So if you read through this, we're on the moon, and objects that are dropped increase by a rate of 6 feet per second each second. So, number 1, create a table for the speed of an object that is dropped from a height of 200 feet. So you're 200 feet above the moon. Because gravity is not as strong there, things are not going to accelerate as fast as they would on Earth. So make a table. This is going to be time, and this is just going to be speed. So at time 0, the object is still in your hand, he's not moving. So his speed is 0. At time 1 second, you're going to drop it, and his speed increases. Where is it? His speed increases 6 feet per second each second. So at the end of the first second, his speed's going to be 6. At the end of the second, it's going to be 12. At the end of the third, it's going to be 18. At the end of the fourth, he's going to be 24. Fifth, he's going to be 30. 6, he's going to be 36. 7, he's going to be 42. So 7 seconds in the air. At the very end of that 7th second, he's going to be traveling 42 feet per second. Alright, that's number 1. And I guess we could keep going. Number 1.5. Add another column to your table that totals the distance the object travels each second. So I'm going to go back. Maybe. Okay. Now this is going to be the distance, but not the total distance. This last column is going to be my total distance. Okay, the distance is just going to be between the interval of each second. So right here, this interval right here, between 0 and 1 second. So he starts off not moving, but he ends up going 6 feet per second, and he is traveling for 1 second. So distance equals rate times time. My time is always going to be 1 second. So the rate I just multiply by 1. And the rate, you have to use the rate that is smack dab in the middle of the slowest and the fastest. At the slowest, he was standing still. The fastest, he's going 6. But he was not going 6 for very long. He was only going 6 meters or 6 feet per second for a little bit. So the speed that's right in between 0 and 6 is 3. So the distance is going to be 3, and he travels that average speed for 1 second. So I do 3 times 1. So at time 0, his distance is still going to be 0 all the way across the board. Okay, now at 2 seconds, okay, between 1 and 2 seconds, at 1 second he's moving now at 6, but at the end of the second he's moving 12. So the average of 6 and 12 is going to be 9. So that means his speed is 9, and he travels that average speed of 9 for 1 second. 9 times 1, the distance is going to be 9. Okay, the third, 12 and 18. The average speed of 12 feet per second, 18 feet per second is 15 feet per second. The average of 18 and 24 is 21. The average of 24 and 30 is 27. The average of 30 and 36 is 33. The average speed of 36 and 42, so somewhere right in the middle of those two, is going to be 39. Okay, now this 39 though, that 39 means he only traveled 39 feet from the beginning or the end of the 6th second all the way till the 7th second. So between 6 and 7 seconds he travels 39 feet. So to get the total, I'm going to do 0 plus 3, that's 3. I'm going to take 0 plus 3 plus 9. So I'm adding up each second. Now to this 12, I'm going to add 15. And then to that total, I'm going to add 21. So 27, 29, 48. It's kind of getting disorganized. So we're going to go 48 right here. 48, I'm going to add 27. We're at 75. Now I'm going to add 33. We're at 108. We're going to add 39. We are total of 147. So at the end of 7 seconds, he is going to travel 147 feet. But they are going to, we got that one done, we got that one done. We need to figure out when he's going to hit the moon. If he is 200 feet above the moon, it looks like it's going to be a couple more seconds. So we're just about there. Okay, at the end of the 8th second, his speed is going to be 48. At the end of the 9th, his speed is going to be 54. Okay, the distance he travels between 7 and 8 seconds. The average speed between 42 and 48 is 45. And then the average between 48 and 54 is going to be 51. So 147, I'm going to take that total of 147 and I'm going to add 45 to it. I get 192. 192 plus 51, and I get 243. So somewhere right in between those two is when he's going to hit the moon, which is right between 8 and 9 seconds. So pretty close to 8 seconds, a little bit over 8 seconds. Okay, this one, number 4. Write an equation for the distance the object has fallen as a function of time. So the distance, if I go 0, so this is just time, and this is total distance. 0, 1, 2, 3, 4, 5, 6. It's going to be quadratic. This is kind of the mother of all quadratic functions. Okay, at 1 second he traveled 3 feet. At 2 the total was 12, then 27, then 48, 75, and 108. So if I find the difference, if I look at this pattern, I find out how fast it's changing. It's changing, it's growing. How fast is it growing? 0 to 3, that went up 3, 3 to 12 is going to be up 9. That's going to be up 14. No, is that 14? 27 minus 12. We are 15. And then that should be 21. That's going to be 27. And then that is, how much is that? 33. Okay. So it's not increasing at a linear rate, so I'm going to break down these differences, and I find the difference between 3 and 9 is up 6. 9 to 15 is up 6, up 6, up 6. Okay, now I know it's quadratic, and because I know it's quadratic, I'm going to follow this form, ax squared plus bx plus c. So it has to be of this form. So I'm going to find a. A is going to be the constant rate of change divided by 2. A is 3. I'm going to find c. C is the mate of 0, so c is 0. And now to find b, I just choose x and y. I'm going to choose 1 and 3, so x is 1, y is 3, and now I'm going to sub everything into this grandfather equation. So y is 3, a is 3 times x squared, x is 1, so I plug in 1, leave b a variable, b, x is going to be 1, so b times 1, plus c is 0. So we simplify that, we got 3 equals 3 plus b. That means b must be equal to 0. So if b is 0, a is 3 and c is 0, my equation, a is 3, b is 0, c is 0, y, let's not use y, let's use distance. Distance equals 3 times time squared. That is it right there. Y equals 3x squared, or distance equals 3 times the second square. So if I plug in 6 for my time, and time is in seconds. Then I'm going to do this. The first thing I do is 6 squared, and that's 36. And then I multiply whatever that is times 3. 36 times 3 equals 108. That means at 6 seconds, the distance, the total distance, is going to be 108, and it works. If we try 5, plug in a 5 for time. 5 squared is 25. 25 times 3 is indeed 75. So there is your function for the distance, the total distance an object will travel if dropped at time 0. Your speed is 0. So if you drop an object from rest, so if its initial speed is 0, that function will give you the total distance traveled for any amount of time you plug in. Now 5, write an equation for the height of the object. So we found this. We found it at 6 seconds the distance was 108. So let's write it like this. The distance at 6 seconds, kind of function notation, distance at 6 seconds equals 108. Now 5 is asking the height above the surface of the moon. If you dropped it from 200 feet above, I'm just going to take 200 minus 108, and the distance above the surface is 200 minus 108, so we're at 90, is that 92? So all you're going to do, you're going to keep your function right here, and this guy, the distance equals 3 times time squared, and the distance from the moon, so distance from the surface will equal this. It's just going to equal 200 take away the 3 times time squared. So if this function right here gives you the total distance and you want to figure out how far above you are the moon, you just subtract, you just do 200 minus your total distance. Okay, look at 6. What if you're on Earth and the rate of increase due to gravity is 32 feet per second per second? So the distance is going to equal 16 times time squared. Number 7, what if your gravity causes it to accelerate at 110 feet per second per second? The distance is going to be the same. It's going to be 110 cut in half, so it's going to be 55 times whatever your time is squared. So 8, the general function for the total distance an object travels when dropped because of gravity is going to be this. The distance is always going to equal 1/2 of whatever your gravity is, whatever your acceleration is. Acceleration due to gravity times time squared, and time is measured in seconds. So there it is. Whatever the acceleration is, you cut it in half and you times that by time squared. Okay, let's look at 3. They want you to find out h of a -2, h of a -1, h of 0, h of 1, so on and so forth. So let's just do a couple. Let's do these negatives. If you plug a negative in there, 10 to the -2, 10 to the +2 is repeated multiplication, but if your exponent is negative, it's repeated division. So anytime you have a negative exponent, you're repeatedly dividing. 10 to the -1. I have a negative exponent, so I am going to move it to the denominator. If you have this, if you have 3 over 5 to the -2, now if your exponent's on the bottom, then you move it to the denominator. It's going to be 3 multiplied by 5 squared. So if your exponent's negative and it's in the bottom, move it to the top. If it's on the top, move it to the bottom. Okay, number 20. They want you to find g of negative 3. So when x is a negative 3, what is the value of that function? So negative 3, make sure you put it in parentheses, plus 2 plus 4. So you have got to include the negative. A negative 3 squared is a negative 3 times a negative 3, which is a positive 9. If you don't include the parentheses, then you're going to get a negative 9. So you've got to include the negative with the 3. So this is going to clean up to be 9. 9 plus a negative 6 plus 4. So we should have 7. Okay, number 24. If you substitute 3 in for x, 5 cubed plus 2 times 3. 5 cubed is 5 times 5 times 5. So 125 plus 6, 131, I think is what p of 3 should be. So p of 3 is 131.